base problem. I'm adjusting it. I can't once again recheck it. Okay. Now okay. Now, voice clear. View also laptop. Nothing, no problem. I think laptop also no problem. Voice should be clear. We'll start now. Charging is on. Charging is on. See, yesterday it was raining, very cloudy. Previous day, when I took the class, it was horrible. And if I continued, I would shout like anything. So yesterday, same problem. So I decided not to take. Unfortunately, there was no problem. 7:30, weather was fully clear. Then I regretted. But what happened is, I thought what happened yesterday, other day, I do not want to repeat it. So I took a chance. Today also there looks like no problem. But remember, this question is completely basic concept oriented. Once this question is over, I am again starting bending shear stress in systematic way there, where this RCC will not come. Therefore, today also, see, right now one small problem. Somebody digging a bore well there, but actually far off place, no problem. Once in a while, that sound will come, discharging sound, that's okay. But if it rains suddenly, and if any problem comes, I will not write on the board, shout like that. I will bring to a stage and stop. And tomorrow, I will start exactly from there. But board will be removed. Why? I have other classes. So, board will, whatever I written there, that you can write down. Information clear? And previous class, information is clear now, what I told? What information I given clear? I won't keep on asking, shall I close, shall I wait for some time? No. Because this is going to remain in YouTube. I do not want disturbances. And last class, around nearly almost 1 hour taken. In the beginning, there was no problem. So, something I told in the beginning, that is still there. I am not deleting it. I am changing that title there. I changed to what? Disturbance is there, retaken. Today I will rechange it. This class is reconducted once again. But remember, go through this class for some more information. I will tell, go through this class for more information, so that today's class I will tell something but won't write. Okay, I will start now. See, as if fresh today, last class is not there. See, question, a rectangular section of a RC beam, see here, RC beam is 200 mm by 600 mm, width 200, depth 600, all in millimeter, is subjected to a bending moment of 50 kilonewton meter. If the beam goes this way, it is this way bending moment. These all I can't tell here. Why? It comes in bending theory once again. Okay. And I told sagging beam. So therefore, when they tell sagging, later bottom is tension, top is compression. Somewhere here, neutral layer. It is not neutral axis. This also I told repeatedly. Okay. Once again. Okay. Sometimes small problems. These things are all okay, no problem. Only people who want stylish class, they will avoid these things. Okay, neutral. Okay. Something happened there because of ink problem. Okay, I don't think. Also, see here, also note, sagging beam, top compression, bottom tension, and somewhere here neutral. Okay, leave it. See, that discharging sound, that will go. Actually, night time, they are not supposed to go for this borewell digging. You can complain, but I got better work to do. Okay, now, what they want in the question is, when this bending takes place here, due to this bending, see, due to this bending, upper side is going to get compression, lower side is in tension. Concrete at the topmost fiber, because sagging, here will get maximum compressive stress. That symbol I will put FCC maximum. Stress in concrete in compression maximum. I read somewhere, I read once again. Maybe last time I interchange. Stress, F stands for stress. I am not using sigma because RCC, working stress method, sigma stands for permissible stress. Okay. Here, today we don't know any property of concrete, no property of steel. First of all, it is not known which steel is used, which concrete used. Indirect hint is there here. That you don't bother. It is a strength of materials question. Okay. Now, or in strength of materials, bending for a member of composite section. Remember. But unknowingly, RCC. Find maximum compressive stress developed in concrete and tensile stress developed in tension steel. That is here. That is stress in steel in tension due to given bending moment. Take modular ratio 13.33. Remember, regarding modular ratio, I told last time. Today briefly I will tell. If you want further information, go back to strength of material, go to stress and strain chapter, study member of composite section, and for those who are in BSK, I told thoroughly for you, yes or no. This class is for BSK batch. For BSK batch, very clearly I told with the money matter example also, what is what? What is modular ratio? So others, they have to believe me. For that matter, everybody who come to my class, they have to believe me. No other way. Okay, start. Now, I will first write cross section as per given data. And one more thing. The steel 4 bars of 16 mm diameter are used at effective cover of 50 mm. Actually, in a width of 200 millimeter, 4 bars of 60 mm diameter is very difficult to place. I forgot that width is 200. Somebody can question. 4 of 16 if you place here, 80, 120 gone. 1, 2, 3, 4, 5. 120 by 5 is 20. Around clearance of 25 mm comes in between. Okay, adjustment. Actually, I forgot that. I would have taken only 3 bars. Width is 200. Later, today when I was writing the sketch, I realized in width of 200, 4 of 20 mm bar is difficult to place. Okay, no problem. This is not RCC class. If anybody questions that way, I will answer in the RCC class. Or I will place it. Maybe it may not satisfy some requirement. No problem. Today we will find the stress and dismantle the beam. And what? We will dismantle this beam. We will completely what? We will take out this beam and break it. Okay, now they are told effective cover 50 means from tension edge to center of steel, that is 50. So from the extreme compression edge, top edge here, to center of steel is 600 minus 50, 550, not given. Instead, it is calculated. You should know that one. It is not given. It is calculated value. I rounded off. Over. Start. Now, you forget about RCC. You come to basic bending theory. That is, you are in strength of materials. You do not know anything about RCC. Neither you know nor I know. Okay. I will do one thing now. From my here, I will remove full RCC. 1 minute now. Before I remove, I should tell one thing. You write here. In the question only write. Tension, concrete in tension zone is to be, what, tell me? You write in the question. In the question you write. In the question you write. What extra data or extra information right there. Please or kindly. What? Please or kindly. concrete in tension zone is to be, tell what? I forgot right here. Is to be neglected or ignored. Someone will tell, he has not told. I am telling here. You write in the question, ignore the concrete in tension zone, over. So, where tension comes, we have only steel. Concrete is removed. It is not there. Right. Now, note, this is already told. Now, I want cross section. Remember, those who want write. In strength of materials, I told you, when you write the cross section, see, upper side is in compression, lower side tension. Tension taken only by steel. So, if the neutral axis comes somewhere here, see, I written here, you know, neutral axis passes through CG of the cross section. So, let y bar be distance of CG from extreme compression edge. See here, y bar. This, you write here, this is the area of concrete in compression. You should write, because I won't write those things. If you are lazy and don't write, don't understand. That's all. This is the area, you write here, this is the concrete area in compression. Now, below, complete empty, nothing is there. Oh, sorry, I removed that axis only. Okay. Neutral axis. And I'll change the red color pen for a little dark one. So that, okay, now okay. Below, you have 4 steel bars of 60 mm diameter. Anybody talking about covers all, keep quiet, I will tell. Someone told this way, okay. You imagine, somebody told, he is placing 4 of 16 in the width. Why should you bother? This is not RCC class. Oh. Actually, I should have given 3 bars, or some 3 of 20 mm diameter, or 2 of 25. By chance, I put 4 now. I thought width is quite more. Then I thought I taken around 230 or 300, but I took only 200. Okay, no problem. Here, nothing is there. So below, from the top edge, at exactly 550 millimeter, we have 4 bars of 60 mm diameter. I wrote blue color. Remember, blue color is steel. Now, this is the cross section, right here. Cross section considering equivalent concrete area. This is really concrete. See, this is really concrete. This is not concrete. That is steel. Therefore, you should not forget. What, tell me? Should not forget. Make a note. I write here, you should make a note. Should not forget that this is to be converted to equivalent concrete area by multiplying the area by, I am removing, by multiplying the area by, tell what? By multiplying the area by, first, you have to convert this steel into equivalent concrete by multiplying the area by modular ratio M. By modular ratio M. You should write. I will tell you all information. M. Like, easy to understand. See, in India, we take rupee, American dollar. Imagine $1 equal to 75 rupees. Suppose I have $2 and some 100 rupees. I cannot tell the money is 102. What I will tell? 100 rupees. I being an Indian, I will solve in terms of Indian currency. 100 rupees plus $2 multiplied by 75. That is the conversion factor. It becomes what? 150 rupees plus 100, 250 rupees. 250 rupees is equivalent money in rupee. Or I can do other way. I can take $2 plus 100 rupees, divide by 75. Why? Because I am converting dollar to rupee. So you can do one thing. Rupee to dollar. So rupee being of lesser value, you have to divide. See, steel is stronger. So multiply by M, it will change over to concrete. Only imagination. Steel will remain steel only. Nobody will go change the steel to concrete. Over. Now, note, there dictated, write everything what I tell here. These all you write. You can write including dollar rupee also. Now, when you take the cross section, compression side write concrete, tension side show steel, but with a warning, it is to be converted to equivalent concrete. Then only you can do the calculation. Over. Start. Now, I want to locate neutral axis. Strength of materials or engineering mechanics, we will take moment about the top edge. Then formula. A1y1, A2y2 divided by total area. But remember, when you find y bar, when you take area of steel, it should be converted to concrete, equivalent concrete. Start. Area of this compression, 200 into y bar into its center of gravity from here is y bar by 2. Okay, plus pi by 4 of 16 square, one circle, into 4, all the 4 bar area. This is steel area. Multiply by modular ratio 13.33, converted to concrete, into from CG here to top edge is 550, divided by that area 200 into y bar plus this equivalent area pi by 4 16 square into 4 into m, y bar will come 195.067 millimeter. This we got to see from the photo of last time. I noted down something here so that I can save the time. This is the y bar you got. Okay, now one make a note. Actually in RCC we don't do y bar that way. In RCC what you do is, instead of taking moment of about a reference edge here, we take moment about neutral axis. Then moment of compression area about neutral axis equal to moment of equivalent tension area about neutral axis. So 200 into y bar by 2 compression area moment equal to this area into modular ratio m into from here to here is 550 minus what? Y bar, equate, you will get same y bar. Tell me, did we get the same answer last time? Yes or no? Did we get the same answer last time or not? What I wrote here, is it all tallying? Yes. Okay. Now, that is clear. Now, these all I will remove. Why? I want space here. So, see, this will still remain. This I will remove, but I will tell you compression at the top, tension bottom, because why? No space. I will remove this A bar, A1 bar, A2 bar, etc. Not required. Section will be still there. Okay, this also I will remove. This also I will remove. Actually, border, I should put a border line here. I should not go beyond this line. Okay, I will remember. Little this side better. Beyond this line. Okay, now M by I equal to F by Y. I will explain once again. F is the bending stress at Y from neutral axis due to bending moment M. I is moment of inertia of cross section about neutral axis. Therefore, now you require moment of inertia of cross section about neutral axis. This was where I wrote on the board where my voice I myself could not hear. I tried some, my mouth was moving, then I decided to stop. Yes or no? Up to here, last time thoroughly told. Then the class stopped. Yes, okay. Now, when you do moment of inertia, some ink spreading is there. Remember about notice in terms of, see, I told you we are solving based on equivalent concrete area. So, in terms of equivalent concrete area, equivalent concrete area, that what we want. That means, write a note, I am dictating. When you find moment of inertia, use Parallax's theorem. Then, concrete keep quiet. Whatever comes, write as it is. But steel, whatever you get, multiply by m, because moment of inertia is in sigma of dA into y square. Y will not change. dA change, area changes means I will change. So Even for moment of inertia also, conversion factor is m. Clear? For moment of inertia also, for steel, conversion factor is m, modular ratio. Fast tell me. Because moment of inertia is area into distance square. Distance I am not changing. Area at m time means, so m or equal to, see, I about neutral axis for equivalent concrete area equal to, see here. Use parallax theorem. One more thing. This class I am not wasting time explaining parallax theorem. People who study all these things and want to gain more knowledge, they should know at least what is parallax theorem. If anybody tells, I don't know parallax theorem, I will tell why you are coming here first of all. Without knowing parallax theorem, there is no point. But I will not ask the question in the class that do you really know the meaning of moment of inertia? Newcomer people will tell, yes sir, yes. Those who already know me, they will tell, we don't know. They know very much. Why they tell we don't know means, I will start telling something else then. I will tell, look at a beam. I can see moment of inertia. ಕನ್ನಡದಲ್ಲಿ ಎಲ್ಲಿ ಸರ್ ಅಲ್ಲಿ ಅಯ್ಯೋ ನಾಟ್ ವಿಸಿಬಲ್ ದೇರ್ ಫೋರ್ ಯು ಡೋಂಟ್ ನೋ ದೇರ್ ಫೋರ್ ದ್ಯಾಟ್ ಇಸ್ ಫಾರ್ ಫನ್ ಓನ್ಲಿ ಐ ಟೆಲ್ ನಾಟ್ ಟು ಡಿಗ್ರೇಡ್ ಎನಿಬಡಿ ಪೀಪಲ್ ಇಫ್ ಐ ಆಸ್ಕ್ ಡೂ ಯು ನೋ ಸಮಥಿಂಗ್ ಮೀನ್ಸ್ ದೇ ಯೂಶುವಲಿ ಟೆಲ್ ವಿ ಡೋಂಟ್ ನೋ some people tell we heard of it, they are very good actually, still they don't want to commit. Why? They know, if they tell we know they will think what this person is going to ask next time, therefore better escape. Tell we don't know. Okay, leave it now. Newcomers will tell we know. After 3-4 classes in colleges I have seen, first class you know everything SFBM, yes sir. After 4 classes SFBM, no sir. Why? That was that day sir, before we knew you. Now we know what you are, now we don't know. Okay, start. I will briefly explain. See, I about any axis equal to Ig plus AH square. That also I should not tell. Start. First, moment of inertia about its own centroidal axis. That is 200, okay, I will put blue color, into, this Y bar, you enter now, 550, go that side. 550, you go that side. Why? Because I want enter here. This is 550, Y bar equal to, any answer, red color adu. There is red color. Hello, it's Y bar. Oh, luckily I noted down. Yes. Oh, I have not noted down. Again I have to go to photo now. Tell the answer Y bar. Forgot. Tell Y bar. Correct number I wrote. I noted, forgot it. Y bar value. I rubbed it. Forgot. 100 and first. What I wrote earlier. Or I have to do one thing. I have to move the 195.067. Thank you. 195.067. Therefore, subtracting, you can find this distance. These are entered values, not given. That will come. I won't ask you because you take lot of time. 550 minus 195.067. 354.933. 354.933 millimeter over. Now, start. I want moment of inertia about this neutral axis. That is, see this axis. Start. Using parallax theorem. First, I about its own centroidal axis parallel to neutral axis. 200 into this distance. Okay, suddenly black color. Okay, no problem. 195.067 cube divided by 12. I think I should remove all this one. This is Ig. This is Ig. Then plus area. What is the area? 200 into 195.067 is the area into from CG of this one to neutral axis this distance square. 195.067 divided by 2 whole square. BB is asking me why you are coming tension zone. I am rubbing it out. This is for concrete. Or if you know a little more principle, moment of inertia of a rectangle about the base is directly BD cube by 3. If you know, you can use it, but I don't use it. Start. Plus. Now, moment of inertia of these 4 bars about neutral axis. You take one of the bar, circle of diameter 16. It is pi by 64 of diameter power 4. That is I for a circular section. Plus area. This is I about its own axis. Area. Pi by 4 of 16 square is the area into CG to here. This distance square is 354.933 whole square. This will give moment of inertia of what? One of the steel bar. But remember, one of the steel bar about neutral axis. I'll do one thing, flower bracket. I'll use a bracket. See, this will give I for one of the bar. 4 bars are there into 4. This will give moment of inertia in terms of not concrete, in terms of steel. So to convert to concrete, without forgetting, multiply by M. What is M? M equal to how much? 13.33. Now 13.33. This will give moment of inertia of these 4 bars about this axis. But actually remember, when you calculate this number, you can skip. Tell why? Because you can take I equal to directly area into distance square, provided dispersion is too much more, self moment of inertia is too small. Here, if you calculate all, if this comes in crores, say 1 crore, 2 crore, 3 crore rupees, then this may be just 20 rupees, 30 rupees. People will tell, leave it. So your choice. Now, see, correct work money, pi by 64. Into 1. Now, this will come. Last time I gave the answer 1884.3912. Someone told not tallying. Later, someone told tallying. Then other also agreed. Yes or no? This is told last time. Correct now? 1884.3912 is correct. Just tell the answer. Was it correct? I noted down somewhere here. 1845. It is 1845, not 1845. Tell me, correct or not? No, I want confirmation. Is the same answer given last time? I wrote somewhere. 1884.3912. Yes, okay. Now, start. I over. Now see, I'll remove all this one now. I'll come here. This 550 I will remove. And I will draw the stress distribution diagram. Remember, sagging, bending. If I continue neutral axis with red color, if I continue neutral axis here, see correctly. If I draw the stress distribution diagram across cross section, upper side compression, lower side tension. This is maximum compressive stress in concrete. I written what? Yep, maximum is maximum stress in compression in concrete. Here, this is stress in what? Equivalent concrete. Stress for equivalent concrete in what? Tell me. In what? Not in compression. In what? First of all, imagination. Stress for equivalent concrete in what material? Stress for nature. Stress for equivalent concrete in tension. In tension. This is not steel stress because this steel is already converted to concrete. So then joined by a straight line. That is what theory? Compression tension. Okay, now start. Now very easily you get the answer. All these I can remove. See, all these I can remove because we are about to close the question now. Not much. See, 184. I'll forget now. Okay. Baba. You don't know how. See, this clearly shows what memory power I have got. I am very weak in what? In biarting things. Okay, start now. Now, Come back once again. M by I equal to F by Y. Start. First, M. Where is M? M is substitute everything in newtons and millimeter. Start. Bending moment M. It is told 50 kilonewton meter or equal to 50 into 10 to the power 6 is in Newton millimeter. If this is not clear, better log out and leave the class right now. Divide by I. I equal to what? I equal to, where is I like that? 1845.3912 10 to the power 6 equal to, see, M by I equal to F. Go to topmost fiber. Maximum compressive stress in concrete divided by, tell me, corresponding Y. For that fiber, Y from neutral axis. How much answer? What is the Y for top fiber? Y for top fiber. Fast. Reply little fast. Don't waste time. Y for top fiber. This lag I should remove somehow. If the lag is removed, answer comes in Zoom class. 195.067. 195.067. Using this equation, see, first I write here now. First, okay, 1 minute now. First, F max CC. First, F max CC. Okay, then I will come to other one. I'll change this pen. First, you go for F max CC. Okay, start. Therefore, you get maximum stress in concrete in compression. Answer. Tell the answer in Newton per mm square. Newton per mm square. Answer. I want for some reason 4 decimal accuracy. Fast answer. I already noted down 65.285. I got 5.2852. 5.2852. I got the answer. So I will enter here now. This is 5.2852. I will enter the answer after calculation. Make a note. Entered after calculation. Okay. Because this is for a principal class. Okay. Over. Now find F stress for, what is the stress for equivalent concrete in tension? Same formula. M by I equal to F by Y. You write FEQCT. FEQCT. Then divide by, tell me, corresponding Y. Divide by corresponding Y. How much I have to write? Corresponding Y. What is corresponding Y? 9 point. Corresponding Y. I am little weak in mathematics. 354.933. Divided by 354.933. Therefore, you get stress for equivalent concrete area in tension. That is, at this level, if instead of steel, if it is concrete, what is the stress? How much answer? I got 9.6167. Is the answer correct? 9.6167 Newton per mm square is the answer. Is that answer correct? 9.6167 is the answer. Over. Now remember now. This is the real answer. This is the real answer. Why? Concrete. This answer is ready. See, note. This is stress for imaginary concrete. Imaginary concrete. Actually, tension resisted by what? Tell me. Tension resisted by what? Actually, tension resisted by which one? Tension resisted by. Actually, tension is resisted by steel. Therefore, if this is the stress for imaginary concrete, the imaginary concrete get the stress. Will steel will have more stress or lesser stress? Think a little. Will steel will have more stress or lesser stress? Further, I am not discussing because this class is analogy for RCC and song, not for this modular ratio all. If I keep on telling that way, there will be no end. That you study in strength of materials. It will be more. Therefore, see, stress, what stress, tell me? Therefore, tensile stress in tension steel, that actually equal to whatever stress we got for equivalent concrete in tension multiplied by modular ratio M 13.33. Tell the answer. Because why? If concrete is taking that much stress, see, concrete area is magnified area. Steel area is contracted. So for the magnified area, if stress equal to 9.6167, when you contract that area, stress will increase proportionally by M. Answer. I got 128.911 Newton per mm square. Correct? 128.911 Newton per mm square. Correct answer? 128.911. Is the answer correct? Correct or not? Correct. 9116 ಮತ್ತೆ 911 ಯಾಕೆ ಬರ್ದೆ ನಾನು? ಹಂಗಿದ್ರೆ 2 ಬರಬೇಕಾಗಿತ್ತಲ್ಲ ನಾನು, ಅಲ್ಲ? ಇದನ್ನೇ ರಿಟರ್ನ್ ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ, 9.6167 ಇಂಟು 13.33. ಅದ್ಯಾಕೆ ನಾನು ಆ ಥರ ಮಿಸ್ಟೇಕೆಲ್ಲ ಮಾಡೋದಿಲ್ಲ. 28.190 ಏನಾಯಿತು, ಎಷ್ಟು ಬಂತು ಆನ್ಸರ್? ಅದು 9.6167 ಇಂಟು 13.33 ಕಮ್ಸ್ ಟು 128.1906. ಓ, ಹಿಂದೆ ಮುಂದೆ ಆಯಿತು. 128.1906 ಆಯ್ತಾಯಿತು. 128. ಅದು ಯಾವುದೋ ಬೇರೆ ನಂಬರ್, ಅದೇನದು 128. ಓಕೆ, 1 ಬೇರೆ, ಸೊ 19 ಇದೆ. 1906 ಹೋಯ್ತು. Now, one important note, I am leaving this earth, I am leaving this strength of materials with the final conclusion that, see, I will remove this one now. I want the answer now. See correctly. If you want, enter the answer. Don't enter here. Why don't enter? Because if you enter, it is imagination. Okay, leave it now. Now I will remove this one and write a note or result. Therefore, by basic bending equation or basic bending theory, that is M by I equal to F by Y or sigma by Y, that is as per strength of material concept, we got maximum compressive stress in concrete equal to how much? 9.6167 Newton per mm square, and we got tensile stress in steel, tensile stress in tension steel, ಮತ್ತೆ ಯಾವ ಸ್ಟೀಲ್? In tension steel, symbol ಇಲ್ಲ, no symbol, equal to 128.1906 Newton per mm square. Or you can write a note here. ನೋಡಿ, ಒಂದು note you should write, those who are interested. Note, my question comes now. Here, you should write a note. See, I told people who want brain teaser or brainstorming question, someone asked earlier. Now answer it now. See, here, moment of inertia is considered or not considered. Illé nodi equation. Here, moment of inertia is considered or not considered. Past. Answer. My question is, moment of inertia is considered or not considered? I want answer now. Moment of inertia is considered. Right. I will ask my brain teaser little later. Answer brain teaser. Wait. I will ask the brain teaser little later. This all I will remove now. See. Now, answer came. All you remove it now. None of them required. Actually, question is solved. Question is solved by strength of materials. Actually, Nowhere in this world, I am sure, I have not seen people solve RCC bending or stress or RCC bending theory problem by this way. Remember, nowhere I have seen. Nobody in the world is going for moment of inertia calculation or putting m by I equal to f by y, etc. No, because RCC, they derive some other equation. Use that one. There, moment of inertia is considered or not considered. Tell the answer. If you use R, now do one thing. Strength of materials closed. Moment of inertia considered. Okay. Go to RCC. I will tell the equation. Bx square by 2 equal to, I am not by arting, I can see there. Bx square by 2 equal to m times AST into d minus x. Equation for neutral axis. M into FCC divided by FST equal to x divided by d minus x. Relation between stresses. Then m equal to b into x into fc by 2 into d minus x by 3 or AST FST into d minus x by 3. None of them by hearted. I can see everything. Some will tell, Yelli Sarunta, oh Alli. There, have you anywhere saw moment of inertia term there? Tell me. Have you anywhere saw moment of inertia term there? Tell me. Have you anywhere saw moment of inertia term in basic RCC equation? Tell fast. Have you anywhere seen moment of inertia term in basic RCC bending equation? Fast. I told all the equation now. I will write it also. See, you are not answering. You know RCC. Have you anywhere saw, did you see anywhere moment of inertia term there? No. Okay. My question comes in the end of the class. For all those who want brain teaser, remember, once I start giving brain teaser in the YouTube class, see how many will follow. One after one. Someone I don't want to tell, he first told, I don't want to tell whom. He told me, sir, time being enough, sir. At present, I am not able to digest. Please give some gap. This way of non-stop firing of questions, he told, I am getting completely blown away. He only asked me, ask some question. I started asking. 3, 4, 5. Answers came. I told wrong. Then, shall I ask next question? He told, no. Let me first try this one. Then only I will ask you. So far, I never got any message from them. Stopped permanently. Okay. Maybe he thought I am not worth. Reason why, still struggling to give the answer. I don't want to tell someone, good concept was there. Okay, now start. Now come to RCC. See, in RCC what you do is, I will tell briefly RCC. First of all, my duty is not RCC. I can only give equation and solve. But still, some will tell, oh, this person does not know RCC. So he by-hearted and came. So I don't have to prove to anybody. I will do one thing. Consider a rectangular section of a RC beam. Perfect concept. See, width is B. This is the area of steel together, AST. Steel now. Somewhere here is neutral axis. Okay. Distance in SOM you call Y bar, RCC we call X. In working stress method, remember I told you, in limit state method we call XU. Yes or no? Limit state method we call XU. Yes or no? If the limit state method we call XU. Heard of it? Working stress X, limit state XU. No answer. At least heard of it or not? One yes. Okay, leave it now. Start. Now, if that is X, this will be D minus X because the extreme compression edge to center of steel is called D. Some people will tell D is distance from top fiber. No, wrong. D is distance from top extreme edge to here if it is sagging beam, or from bottom to there if it is hogging, or generally you should tell distance of CG of tension steel from extreme compression edge. Now, this area is in compression. This is the area tension. This is completely ignored. So, if you draw the stress distribution diagram, see, symbol, here I will put maximum stress in concrete, FC, sufficient. Why? Sufficient. I usually use FC. That FC is nothing but your, what? I use the symbol here, what? F maximum CC. Not required. Simply FC. FC is, in bending theory, permitted is sigma CBC. Remember? That is sigma, permissible. We don't want permissible here. Okay, now see. That is FC. Here, FC. Here, stress in steel is FST. So, FC is maximum. I'll write here now. See, FC is maximum compressive stress in concrete. Compressive stress in concrete. In concrete. And FST is stress or stress, okay, stress in steel in tension. In tension. Now, this is for concrete. This is for steel. No. Now you cannot use any linear function. What do you have to do? If this is concrete, this also should be converted to equivalent concrete. Stress in steel, we want to change over to concrete. Tell me, if the steel is taking FST, stress for imaginary concrete, will it increase or decrease? Ulta now, reverse. Earlier I told, you know stress in concrete. You multiply to get stress in steel. Now, this is stress in steel. I want to get equivalent for concrete. It will increase or decrease. This all theory I told in RCC class for you in the RCC batch. No answer. It will decrease. So what you have to do? You have to take FST by M. And this AST, when you change, it will become M into AST. Yes. See, when you convert the steel to concrete, it will become M into AST, and stress in steel, when you convert to concrete, by M. In RCC, sometimes I tell blindly to our students, do one thing, area conversion, multiply, stress conversion, divide. Sir, got it, sir. Why, see the nature of students? See their spirit. Area conversion, multiply, stress conversion, divide. One small information for you. Recently, I am taking some classes. Now, I observed level of understanding and basic knowledge has drastically gone down. And if the earlier was something study well, see, 2010, 2011, 2012, etc., up to 2020 level. Now you don't know. Suddenly now, level is here. It has come down, drastically down. Anybody can tell the reason? They don't know anything. What is the reason? I know the reason. See, earlier, exam fear was there. You have to study at least something. Now, recently past 2 years, no exam fear. Pass. Everybody pass. Without writing examination, pass. That is because of COVID-19. That's why some people call COVID batch. I observed it as the subject knowledge. Even earlier, there is a limit. I won't tell earlier high level. At least what knowledge they used to have earlier, 2-3 years earlier, those who come to me, now 90% removed. Only 10% is there. Very bad. I think if you are teaching profession, you can make out now. You see now, if you are teaching profession, suppose you have taken a class for 5th semester now. 1, 2, 3, 4 semester passed out. When you take 5th semester structural analysis, you will have such a difficulty, means they will ask, fixed beam, sir, what is that one? Earlier at least they will tell WL square by 12, WAB square by L square. Or at least they will tell what? Bending moment. Now, bending moment, what is that, sir? You know, the standard has gone down that much. Okay, leave it now. Now, FST. And as usual, M is modular ratio. Modular ratio. Okay. Now, import, everything okay now? Just Okay, I can see here only. Now see, therefore the stress variation is like this. I am telling this is compression and tension. See, now I will take one by one and solve. First, I want to locate neutral axis. I want to locate neutral axis. Now, if I come to this question, now our example question here, tell me as a RCC problem, tell the answer, all dimension, B equal to, compare, B equal to 200 millimeter, correct? And then we got effective depth D equal to 550 millimeter. And area of steel in tension, AST equal to pi by 4 of 16 square multiplied by 4. I don't have to calculate 804.25 mm square. Oh, some will tell, see sir, by hearted. No. 4 of 16 mm diameter bar, I used it more than 4,000 times. I know the area. 4 of 20 mm, 1256.64. 5 of 20, 1570.8. Why? Because when you use many times, even if you do not want, answer comes. Sir, 3 of 20, 942.48. Okay, leave it now. Jasti kelbidi. Right. AST. And in the question they told, M equal to 13.33. Now, as I derive, I will solve. To locate neutral axis, see, you write moment of compression, you should write moment of compression area about neutral axis equal to moment of equivalent concrete area for the steel bars about neutral axis, or moment of this area equal to moment of this area about neutral axis, the steel to be converted to concrete. You get B into X is the area into center of gravity is at center, X by 2 equal to, this area is AST, but convert it to equivalent concrete into M into, from here to here is D minus X. Or you will get equation bx square by 2 equal to MAST into D minus X is the equation to locate neutral axis. Okay, I will do one thing now. I will write it somewhere there so that we can apply later. Therefore, I will write here now. This I will remove. This I am removing now. Therefore, to locate neutral axis equation is, to locate neutral axis, the equation to be used in RCC is bx square by 2 equal to MAST into D minus X. Correct? This is the equation for neutral axis in RCC. This all I did in RCC class for you. Okay, now further. Due to bending, maximum stress comes here, compression, stress comes in here. So, from similar triangles of stress distribution diagram, you write here, this is the, you write if you want, stress distribution diagram across cross section for equivalent concrete area. You can tell FC divided by what? X equal to FST by M, or I'll write here, other way, better. Instead of that way, further easier. See, FC by FST by M, FC by FST by M equal to X divided by D minus X. Therefore, if you simplify, you get relation between stress in concrete and stress in steel is given by M into FC divided by FST. FC is stress, actually is FST by M, M jump to numerator, equal to X divided by D minus X. Oh, this is the equation. Okay, now lastly, see. Now, I wanted some space there. I wrote there. Now okay. what to do. Or I want to write something there. Okay, 1 minute. Shall I remove the question? Okay, I will remove the question here. So that I will write here now. So that, why? Because I want that space. See, to locate neutral axis, this is as per RCC theory. Locate neutral axis, equation is bx square by 2 equal to m times ast into d minus x. Already over, derived. And relation between maximum stress in concrete and stress in steel is between Fc and Fst is what? Is m times Fc divided by Fst equal to x divided by d minus x. Actually, I don't have to derive. I can give only equation. But why I am deriving is for my brain teaser. Why I am deriving is for my brain teaser question. Otherwise, I will not derive. Why should I derive? Okay, now, lastly, see, I will remove this one now. Now, I want expression for m. Okay, I will remove this one now. See, now, this concrete area is in compression. So, there is compressive force like this. That force will be acting, force equal to stress into area. So, how the stress varies, same way force will vary. So, there will be a resultant force here called C. And this is ignored. To center of tension steel, a force equal to T. This is lever arm A. See, lever arm A. Now, C is resultant compression force. Compression force in concrete, in compression. And T is tensile force in steel. Now, in general, resisting force equal to stress into area if the stress is uniform. Whereas, if stress is not uniform, it is force equal to average stress into area. Heard of this one? Tell me, at least heard of this one? If the stress is uniform, stress into area. If stress is varying, average stress into area. Valid for working stress and limited. See, working stress, average stress is Fc plus 0 by 2. That is 0.5 Fc. Limit state is 0.36 FCK. That there also same condition. Clear or not? Okay. Now, therefore, your C equal to compression force. Area, what? B into X is the area. This is area. Into stress. Here stress is Fc, here 0 into Fc plus 0 divided by 2. Or your resultant compression force C equal to Bx Fc by 2. Okay. Now, I want tension force T. Tension force T equal to area is m times AST, equivalent concrete, into Fst by m is the stress. M will cancel, or your T will come simply whatever is the steel area into stress in steel. This you know thoroughly in RCC. Now, lever arm A is distance between lines of action of C and T. Since it's a triangle here, this will be acting at point, or not point, 1/3 of X. In limit state method, when the stress diagram comes this way, then average is 0.36 FCK, CG is at 0.42 XU. Remember it? There also same principle. There average is not Fc by 2, it is 0.36 FCK, and CG is not 1/3, it is 0.42 XU. At least tell me, do you remember or not? At least in RCC, do you remember? At least some comparison. Fast. You tell yes, I will get confidence then. Yes. Therefore, now, for equilibrium, your C will be equal to T. two equal unlike parallel forces separated by a distance will form a couple. The moment of the couple, which is called internal resisting moment, will be balancing the external bending moment M. So your M will be equal to either C into A or T into A. Further I won't discuss because this is not RCC class. See now, 1 minute. People who are telling bending moment internal, do you know what they tell? See, people at least now wake up from wrong concept. People who keep on, some are shouting like anything. Bending moment is internal. I pity them. See, people who shout bending moment is internal, do you know what they tell? They will tell beam prop in RCC, they will tell beam internal resisting moment will balance external bending moment. Or in the question they will tell beam cross section is subjected to a bending moment M. When the beam cross section is subjected to bending moment M, is it internal or external? Tell me. When you tell it is subjected to a bending moment M means internal or external. That only will tell you. Tell what? If you tell, they only give the RCC problem. The beam cross section is resisting a bending moment or subjected to a bending moment of M. Means M is what? Subjected to something means what? Internal or external? Subjected to something means external. One class in YouTube with full shouting, I want to awaken everybody who tell wrong concept. Not now, little later. I will tell at least from today talk sense. I will tell later, not now. But I will tell them, see, not for hurting you. It's a fact, it's a truth. Over, now. So therefore, I will remove everything now. None of them required now. See, this also not required, that also not required. I can remove everything now. Okay, 1 minute. Section is still there. Now, see, or I'll write here. Therefore, if you write M equal to C into A, your M equal to C. Where is C? C is BX FC by 2 into lever arm, I forgot to tell. Lever arm A equal to D minus X by 3. In limit state, it is D minus 0.42 XU. See, everywhere principle is same. Okay, now, therefore, if I write M equal to C into A, equation is BX FC by 2 into D minus X by 3. Or see, M equal to, M is the bending moment for cross section, equal to BX FC by 2 into D minus X by 3. Or your M is also equal to, if I write M equal to T into A, it is AST into FST into D minus X by 3. Right here. Or you can tell M equal to AST into FST into D minus X by 3. You can tell this is expression for M based on compression. This is expression for M based on tension. Tell me, at least actually in our class, RC theory I need not derive. I should have directly told, see, you know that, even I also know that in RCC, equation for neutral axis, Bx square by 2 equal to MAST into D minus X. Relation between them is M into FC divided by FST equal to X divided by D minus X. M equation is Bx into FC by 2 into D minus X by 3 or AST FST into D minus X by 3. But still, I proved it. Good for inform. At least you should tell. Those who are not knowing earlier, they will tell. At least now you know it. Good. At least from me. If they understand that much, some what satisfaction for me. Okay, now. M over. Now tell me. For our question now, your bending moment M equal to 50 10 to the power 6 Newton millimeter. Okay, now tell me. Okay, see, now my brain teaser question comes now. Just now I derived the RC theory. Fast answer it. All those people who want brain teaser, Now answer my question. See, I will tell my question here because some people they want brain teasers. One person commented, where is the brain teaser? He does not know how many brain teaser will come. See, I will write here. Those who are serious brain teaser or brainstorming question or what we call is tricky concept question. Answer. See, tell it here. Earlier I used moment of inertia concept, you know it. Now, at present, when I took bx into x by 2 equal to this area, when I use similar triangles or when I put c into a or t into a, tell me, did I use in one place moment of inertia? My question. In the RCC theory just now, in the RCC theory, just that's why I derived it. That is why I derived. In the RCC theory, just now derived by me, did I use moment of inertia even once? Tell me. Even once. Did I use moment of inertia? Fast. Answer. Even once. Did I mention moment of inertia? You have to answer fast. No time. Did I use moment of inertia even once? In the RC theory, don't go to SOM. No. That means in strength of material, moment of inertia concept is used. Tell yes or no. In strength of material concept or in strength of materials basic bending equation, moment of inertia concept is used. You have to tell yes or no first. In strength of material, that is basic bending equation, moment of inertia concept is used. Yes. But in RCC theory, for working stress method, popular version, moment of inertia principle concept is not used. Yes or no? Is not used. See, show me. Where used? Is not used. Tell yes or no. Is not used. You have to tell yes or no my answer. Like what I am telling. In RCC theory just now derived, moment of inertia principle or the term moment of inertia concept is not used. You are not answering the question. Am I telling correct or wrong? See, delaying means waste of time. Just now in RCC, yes, strength of materials used, you know it. RCC not used. Now my question to you. See, not used, not used. Nodi, I am seeing now. Now do one thing. I will go and see used or not. Used. People ask, sir, where, sir? There. See, Alnodi, ide. It is there. It is there. Tell me, where is it there? Tell me, where is it there? Hidden inside. Hidden inside. Kannadadalli agochara. Hindi. Forgot. Not agochara. Hindi. Gayab. Gayab alla. Gayab andre parari. दिखता नहीं मगर सोच सकता हूं. सी दिखता नहीं मगर है कुछ है. I don't know word. Yes. So my answer, people who want to brain teaser, now answer my question. Tell me where is moment of inertia here. Tell. Now answer. Then ask me more brain teasers. Remember, some of the brain teaser I am asking will be so powerful that some people will tell, no, I don't want anything more. If this way you can ask brain teaser, they will tell, I do not want to study anything. Okay, leave it now. Now it is for you to search. You say what? Magnifying glass and search it. Use some magnifying glass, search it. Further magnify. Somewhere there, moment of inertia is there. That's all. My brain teaser question is over. Now answer. Show that those who are eager to answer, now answer, then only talk further. then only talk further or comment anything else. Why? Because someone asked me, sir, in the 100th class, you asked brain teasers are there. Where are they? Yes, one came now. This is what, first you digest this one and next go to other one. Okay, now I will remove everything now, and now what I will do is, lastly, 10 minutes more, I will solve the same question by RC theory. See now, fast. I hope that result will come same as what we got. Where is the answer? See, you know the result here. I sincerely hope result will come same as what we got by strength of materials concept. Tell me. Please wish me good luck. I need your good luck now. See, I am going for, instead of some concept, I am changing over to RCC concept, where to ordinary person, moment of inertia is not visible. It is visible. Okay. Like happiness, not visible, but you can feel. Hungry, you can feel. Happy, you can feel. Angry, you can feel. You cannot see it, you can feel. Here, moment of inertia, see, I will see here now. Oh, yes. ಕನ್ನಡದಲ್ಲಿ ಕಾಣಿಸ್ತು ನಮಸ್ಕಾರ. ಹಿಂದಿ, oh, ಪದ ಚಲ್ ಗಯಾ, ವಹಾ ಹೈ. English, yes, it is there. Where means search. Over. Now I am taking a risk now. I am solving the same question what I solved by strength of materials concept. Apply RCC derived equation. Hope I will get the same answer. For that, from your side, I prefer, if you wish me good luck. If you wish me good luck, see, if answer is not tallying, my teaching profession is at reputation. Reputation is at stake. Now, in case answer is not tallying, my teaching reputation is at stake. Can you wish me good luck? Can you wish me good luck? Or you tell, I don't need good luck wish. What do you feel? You can wish me good luck to encourage me. Or you can tell, in Kannada, na bada bidi sir. Hindi, nahi chahiye. English, it will come. Where it will go? Okay, shall I start? See, nobody is wishing me good luck. Taking a risk. I am putting my profession at stake. No good luck, nothing. Or everybody wants me to fail this time. Are anybody hoping? We hope that this time he will go wrong so that we can laugh at him. Don't hope too much. Start. Now start. First, RCC theory. Hope that answer will come. First, locate neutral axis. Locate neutral axis. First equation. Bx square by 2 equal to MAST into D minus X. B, 200 into x square by 2 equal to 13.33 into 804.25 into 550 minus x. Solving, get x. This will tally because why? This is strength of materials only. This tallying is no advantage. So x will come. Answer. First, RCC theory, I got x value. Answer first. 195 point, how much? X value. Bega. 195, I remember still. 195 point, number first. I forgot. See how much I remember. You are not answering. Don't waste time now. 195 point. I somehow remember 195. I don't know. Early the 195. I am not in any. I rubbed everything. If you waste time this way, what I can do? 195.067. ಆಯಿತು. 195.067 millimeter. Maditeli. 067 millimeter. Over. Now this I will remove. X over. See, this tallying has nothing to do with moment of inertia. It is same as SOM. Now important. Now I want to find FC and FST. Stress in concrete compression, that is nothing but this number. And FST, that is nothing but this value due to M. Okay. Option 1. I will go for option 1. Use M equal to Bx Fc by 2 into D minus X by 3. Start. Substitute M. 50 10 to the power 6 equal to 200 into x is 195 point. See, I am slowly getting tension now. See, my hand is trembling. Why? If answer is not coming, I cannot continue class tomorrow. Hope that I will get the answer. Divide by 2. Some will tell, sir, drama ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅಂತ. ಡ್ರಾಮಾನೇ ಮತ್ತೇನು? Answer, any chance of answer not? ಅಯ್ಯೋ, D. 550 minus 195.067 divided by 3. Please kindly save my life by giving FC value same as what you got there. Fast answer. Moment of inertia is there. Where? It is there. ಕನ್ನಡದಲ್ಲಿ ಸರ್ ಎಲ್ಲಿ ಸರ್? ಅಲ್ಲಿ. ಹಿಂದಿ ಸರ್ ಕಹಾ ಹೈ? ವಹಾ ಹೈ. ಇಂಗ್ಲಿಷ್ ಸರ್ ವೇರ್ ಇಸ್ ಇಟ್? ಇಟ್ ಈಸ್ ದೇರ್. Inner mind, it is there. Tell the answer. I have absolutely note for that matter. I did not bother to check this value. Answer. Answer fast. Now everything in your hand. If you tell the answer is tallying, tomorrow onwards class will be there. If answer is not tallying, today will be my last teaching day. Today will be my last teaching day. If answer is not tallying, from tomorrow, no more classes. No talking of structures. Fast answer. Only possibility is calculation mistake. In that case, I will check again. See, if a calculation mistake is there, I will check once again. No problem. Fast give the answer. Take everything. Oh, yo, I have not written FC. BX into what? Our important is what? FC by 2. I forgot right only. FC by 2 into 550 minus 195.067 divided by 3. Fast tell me FC value and strength of materials value we got is 9.6167. See, 9.615, 616, 617 will do. You are not giving answer. Same. How much you are getting? Same answer? Same answer. Okay, therefore, class will continue. 9.6167. Someone, I won't tell, who heard me talking this way in the class, he commented me. Someone, he told, if you talk this way, if you get stuck in the class, you will have no face to show them. You will be royally what? Insulted by them. He told, this is dangerous. Your way of talking and the way you show what? Aggression and what? Tell, answer has to come this much. Otherwise, I will not teach. They are dangerous, he told. I told, they are dangerous anywhere else. If I tell I will come in 15 minutes, dangerous. But it is not dangerous in structures because structures it has to come. Okay, answer. FC over. Now, use the equation MFC by FST equal to x divided by d minus x and get the FST. Start. M 13.33 into FC 9.6167 divided by FST equal to x. Where is x? 195.067 fx divided by d 550 minus 195.067. Tell me the FST value. Fast tell the answer. This is stress in concrete. This is stress in steel in Newton per mm square. Tell the answer first. This is option 1. I will give you both the option. Bega. 5 point. Oh, sorry. It is 9.16 Allah. Sorry. What is answer? It is not 9.16. Tell what is answer? Oh, this is a wrong copying. That answer was 5 point. How much? I forgot. See, 9 is not possible. See, okay. I will go back here. I do not want any compromise here. 1 minute. I will go to earlier version and check what is that number. No chance to be taken. 1 minute. It is, see, otherwise, one minute now. 5.2852. Oh, print mistake. It was 5.2852. That 9 point was something else actually, correct? That was something else. That was equal stress in tension, I think. Okay. Is the answer same now? Tell me. 5.2852. Is the answer tallying or not? Sum also 5 point. See, that's a wrong. It is called print mistake. When I noted the answer, I noted wrong answer. First, answer tallying or not? I want to close the class now. Just 3 minutes more. See, if you don't reply, what happens is difficult to continue. 9 point, 5.2852. Is the answer correct or wrong? See, lastly, you are not responding. Yes, okay. Now, substitute here. Tell FST. No. This will directly give stress in steel. There you get stress in concrete, convert to steel. In RCC, your equation is directly stress in steel. Answer. In RCC, equation is directly stress in steel. Answer. Tell the answer here. First. Sorry, not 9 point. See, ayo, 5.2852. Print mistake. Answer. Cross multiply and tell FST. Really calculate. Don't tell same as last time. Not same as last time. I will take care. I will stop the class. 128.19. Thank you. 128.19. Tell me, how much answer we got by SOM? Tell the answer. Strength of material answer. 128.1906. 1906. Oh, that is okay. Rounding off error. That is 100% result tallies with the same as strength of materials approach. Tell yes or no right here. 100%. Not even one micro difference. Result tallies with what we got by strength of materials. Tell me, agreed or not agreed? Agreed or not agreed? 100% result tallies. Yes. Now, or I will tell option 2. I am closing now. Option 2 is, if you here see, first find FC using link find FST. Option 2 is first find FST using link FC. You write M equal to option 2. AST into FST into D minus X by 3. Okay, start. Substitute. M. 50 10 to the power 6 equal to 804.25 into FST into 550 minus 195.6067 divided by 3. You are first getting what? You will first get FST. I will calculate, don't worry. I will calculate. Now, first steel will come. I will calculate. You don't calculate. Got it? 128.19 Newton. Oh, same answer. And now, use the basic equation. FC you make unknown. FST you substitute 128.19. You will get calculator. There's a calculator there. You will get his answer. 5.2852 Newton per mm square. See, in the RCC class I told, use expression for M based on compression, get compressive stress, use the link and get tensile stress. Or use the expression for M based on tension, get the tensile stress, use the link and get the compressive stress. Or use expression for M, get the compressive stress, use the expression for M, once again use tensile stress. You can do whatever you want. Therefore, tell me, basic bending theory and RCC theory, even though looks completely different, both are giving same answer or not. Both are giving same answer or not. First, both are giving same answer or not. At least in my class, other class I don't know. Anybody's class, if properly taken and correctly told, it will tally. See, no response. Correctly tallies answer. Yes. Now, see, for the brain teaser, tomorrow class, if you want, only if you want, tell me. I don't have to prepare. Right now I can do it. How I derived the bending equation for RC beam, Bx Fc by 2 into d minus x by 3 or Ast Fst into d minus x by 3. If you want, I can derive that equation using strength of material concept or using moment of inertia concept also there. If I tell how to derive that one, then you will go near and near to searching for moment of inertia. Tell me. If you want, tomorrow I will tell, half an hour it will take. If you want, I will tell. See, I derived what? Average stress area, lever arm, none of them. Directly sum. RCC also use m by I equal to f by y and derive the equation there also. It will come same equation. Then your search for that moment of inertia, you will be nearer. You get extra idea then. Tell me. If you want tomorrow, half an hour, I will do it. So, I am sacrificing my further class. By doing all this, I am taking more and more class for basic knowledge. Somebody who want to finish subject fast, by this time, he would have finished subject and started a new batch. But no, I will give maximum information. Tomorrow, first half an hour, I will use basic bending equation with the moment of inertia and prove RC equation. Then I will tell. Now if you look here, you can see moment of inertia compared to yesterday, nowhere visible. Now faintly visible. See, you will tell. Earlier, nowhere visible. Now faintly visible. I know. It will be faintly. Salpa. Thoda sa dikh raha hai. Sir, thoda lagta hai moment of inertia. ಕನ್ನಡದಲ್ಲಿ ಯಾಕೋ ನೋಡಿದ್ರೆ ಒಂಥರ ನೋಡಿದ್ರೆ ಐ ಥರ ಕಾಣ್ತಾ ಇದೆ ಅದು ಎಲ್ಲಿ ಗೊತ್ತಿಲ್ಲ. Shall I do it? Okay. Tomorrow I will do it. Today I will close the class. At least this class, I had taken the class once again. Everything in one stretch. Really useful for those who want to learn the concept. Really useful, at least some concept based. I don't know. You feel if it is not useful, tell me. I won't take such classes. Okay. Hope it is really useful. At least you will learn something more now compared to earlier. Okay. Thank you. Tomorrow you will meet. Tomorrow also same thing. In case suddenly weather problem comes in any class in future, if it is in YouTube, what I will do? I will stop. If it is in Zoom, I can pause. No problem. In Zoom I can pause. In YouTube, I can't pause. Actually, pausing is possible, but I don't know how to pause. If I try to pause, it will end the meeting. Okay. YouTube class, if horrible situation comes, I will stop there. Next day, continue from the same day. I will write same class continued. Okay. Thank you. Study everything what I told today. Understand. See, one small mistake, not mistake, wrong writing. But anyway, he can make out. It was actually, I copied the wrong answer, but I know answer will come. Thank you. See you tomorrow then.